we will discuss gravitational potential. First of all, I will define gravitational potential. What is gravitational potential? A few definitions of gravitational potential. Throughout this topic, I will be writing gravitational potential as just Gp. So I will say gravitational potential or Gp is equal to work done upon mass. I will define in other way also. I will say it's the work done per unit mass while bringing it from point of infinity to that point in gravitational field. This means that suppose if this is the mass of the body due to the gravitational field exists, and this is the region of the gravitational field, and this is the point of infinity. If suppose a body of mass m is brought at point A, when a body of mass m is brought at point A with constant speed, when it is brought at here A, there must be some work done. Work done divided by this mass will be always a gravitational potential. And the third definition in mathematical language, I can say phi is equal to W upon m. And what's phi? Phi is gravitational potential. W is work done, and m is mass. So I can always say work done per unit. These work done per unit mass. These all definitions are same. The definition is very important. We should prefer actually this definition, but this is also okay. Examiners do recognize this definition also, work done upon mass. Very simple. So this is the definition. What will be the SI unit? It is clear from this one. I can add what will be the SI unit of phi or SI unit of gravitational potential will be. You can see this is the work done is joule upon kg, or I can say it is joule kg power minus 1. So SI unit of gravitational potential is joule per kg. Let us see what the formula is. We have to recall the formula for the gravitational potential. Actually, if suppose again I will be driving this is the mass m, this is the body due to the gravitational field exists, and this is the gravitational field, this is the point of infinity. Suppose if I want to find gravitational potential at point A. Now suppose this point is at a distance of r from center of the body due to which the gravitational field exists. I define the gravitational potential at this point by the formula we do work done per unit mass. But what is the formula? We have to recall that formula. The derivation is not in our course. I can say phi is always equal to minus gm upon r. Phi is gravitational potential at this point. G is the, you know very well, G is the universal gravitational constant. M is the mass of the body, M capital, due to which the field, gravitational field exists, and R is the distance of this point from center of the body. Although in definition we do from this, but actually in formula it comes from this one. It is the distance from center of the body. Now, since work done is always potential energy, here it will be gravitational potential. We know phi is W upon m, or I can say W work done phi into m. So I can always say that gravitational potential energy is also phi m. Means gravitational potential energy, I can always write the gravitational potential energy is equal to gravitational potential into mass. But which mass? It is not the mass of the body due to which gravitational field exists. It's the mass which is placed at the point A. So if suppose here is the phi is the gravitational potential, and gravitational potential is phi, which is minus g upon r. So EP is equal to phi m. So EP is equal to phi m, and then EP I can say EP will be phi is minus g upon r. So I can say EP is minus gmm upon r. So this is the formula for gravitational potential energy also. So there are two very important formulas in this chapter. One is the gravitational potential. That's phi is equal to minus gm upon r. Other is the gravitational potential energy. It is minus gmm upon r. So these are the two formulas. Now forget about the formula of EP is equal to mgh, because that was the formula which was used in our AS level, but that is actually varied when G is near the surface of the earth. The G varies, so this formula is no more varied, but it will be varied near the surface of the earth. Generally, we have this gravitational potential energies formula taken. So clearly these both quantities are negative. Why gravitational potential and why gravitational potential energy are negative quantities? We have two approaches. By one approach, they can say why gravitational potential or gravitational potential energy is are negative. Why they are negative? Actually, suppose if there are two approaches, I will tell you. This is the mass of the body due to which the gravitational field exists. I always take this with the capital M. And this is the mass of the body. I suppose I want to find gravitational potential at point A, and the mass of the body which is broad at point A is M. Now, if this body is broad, you know this M capital is attracting this body of mass M. So I will first write gravitational forces are attractive in nature. You should always write this first. Gravitational forces are attractive in nature. So they are attractive in nature. So it means if this body is a load, it will be accelerating due to this force. Okay. So in order to avoid acceleration of the body, a force opposite in direction to gravitational force but equal in magnitude is applied. Clearly, suppose if this is the mass M, this is the gravitational force. Now, due to that, body will be accelerating. So I have to apply an equal and opposite force upward. So this applied force is upward and displacement is down. So there's the angle, the force is upward and this displacement is down. So clearly, angle between these two is 180 degree. And work done is FR cos 180, so work done will be negative because the displacement is against the direction of the force. So I will say work done by this force. This force is negative. If work done by this force is negative, it means hence gravitational potential or gravitational potential energy is R negative. So that is clearly the thing we are approaching in a one way. One way is first we write gravitational forces are attractive in nature, so we have to apply an opposite equal force in opposite direction. Work done by this force, not by this force, work done by this force, because you have to apply so that body is not accelerated. So work done by this force is negative because displacement is down and force is up. So work done by that force is negative. So work done per unit mass is the gravitational potential. So gravitational potential is a negative. If gravitational potential is a negative, gravitational potential is negative. This is one approach. Other approach is very easy. You can first write this. Gravitational forces are attractive in nature. First write this. Then you should write as we go higher. It's a very simple approach. Students love this approach, but examiners love to have the marking on the first approach better than this one. This is also okay. As we go higher, gravitational potential or gravitational potential energy increases and becomes maximum at point of infinity. Since it is maximum at point of infinity, and this maximum value is 0. Maximum value is 0. Clearly, suppose here at this point, this is the gravitational, this is the body, this is the point of infinity. Here at this point, potential energy is 0, also gravitational potential is 0. But this is the maximum. If you go higher and higher, suppose this is A point, this is B point, the gravitational potential at point B is higher than the gravitational potential at point A. So if you go higher, gravitational potential increase. It means if they are increasing, so and maximum is 0. It means if maximum is 0, all of these values must be negative. Hence, all other values must be negative. This approach, all other values must be negative. This is the our values must be negative. This is a very simple approach. Very simple approach. I can say, first thing, always write gravitational forces are attractive in nature. Second, write if we go higher and higher, gravitational potential or gravitational potential increases, and it becomes both becomes maximum at point of infinity. But maximum value, gravitational potential or gravitational potential is 0 at maximum point the infinity. So it means all other values must be negative. Now sometimes we have the graph of the gravitational potential against the distance from surface from the radius of from the center of Earth. Suppose if this is the Earth, its mass is capital M, its value of mass is 6 into 10 power 24 kg, and suppose the radius of the Earth is always 6.4 into 10 power 6 meters. I have to calculate the gravitational potential at surface this, and at suppose distance of what? 2 RE from center, and then at 3 RE from center. So these are a few things, and I will be plotting a graph because this I will write this gravitational potential phi is a negative quantity. It will be coming in megajoules per kg, and this is the distance from surface, distance from center of Earth. Now at 0, this is the first radius of Earth. If I calculate value, phi is equal to minus gm upon re, and I put the values minus 6.67 into 10 power minus 11 into 6 into 10 power 24 and 6.4 into 10 power 6. I calculate, it comes out to be minus 62.5 into 10 power 6, or I can write minus 62.5 megajoules per kg is a negative quantity. So I have labeled this megajoules per kg. Now at Re, this value is this minus 62.5 megajoules per. I am giving this dotted line. At a 2Re, 2Re means the distance is 2Re from the center. Okay, 2Re, twice the radius of Earth. Here it will come 2, and this calculation will be divided by 2. It comes minus 31.25. And at minus 31.25, this value is this one. I'm not giving this dotted line, I'll be just giving this dotted line for the initial purpose. I'm telling you after this graph. And then 3Re, value of 3R will be here. Value of 3R is almost minus 20 point. I can erase this. I can use these in the formula, and I will be, you can calculate these values. You will see these values are coming minus 28.8, and this value is up to here. So I can have this graph. This will never touch this line at infinity. Now see, I have not plotted these dotted, I only plotted this dotted because it's part of the graph. This tells us, okay, inside the surface of Earth, this is inside the surface of Earth, the gravitational potential is very much uncertain. We cannot define it, or we are not certain. But if it exists, then it should be the same as the surface. That's why this graph is dotted, minus 62.5 megajoules per kg. Sometimes we have the exact values. I can say distance from center of Earth, and I can mark it 10 power 6 meters because radius is 10 power 6. And then I will write this as 6.4, this as 12.8, and this will be then 19.2. This is also okay. Sometimes examiners say distance from, not from center of Earth, but distance is from surface of Earth. If surface of Earth is given, Then you have to shift this axis here. This axis will be shifted here. Okay, again, this is 5 megajoules per kg, but the values will remain same. This is minus 62.5, and clearly this value is minus 31.25, and clearly this value is minus 20.8, and this value becomes now 0. This becomes 6.4, this becomes 12.8, and then I can erase this. Now this is the graph of gravitational potential, or phi megajoules per kg. Again, the distance from surface of a 10 power 6 meter. If it is in RE form, then I can write here, then this is RE, radius of Earth, this is 2RE, and so on and so forth. So this is the gravitational potential. Now again, I'm revising. First, the definition. Definition is work done upon mass, work done divided by mass, or work done per unit mass, or work done by bringing the unit mass from infinity to that point. It's SI unit work done upon mass, joule per kg. It's a negative quantity because, why it's a negative quantity? Because gravitational forces are attracted to nature, and if you go higher and higher, gravitational potential and gravitational potential both increase, and they become zero at point of infinity, which is the maximum point. So all other values must be negative. That's one approach. Other approach is, you can say gravitational forces are attracted to nature. So if a body is allowed to fall, it will be accelerating. In order to avoid that acceleration, equal force in gravitational equal to gravitational force must act in opposite direction, upward direction, and the work done by that force must be negative because the displacement is down, so gravitational potential must be negative. The formula for the gravitational potential, you have to recall, minus gm upon r, and the formula for the potential energy is either m phi, or it will be AP is equal to minus gmm upon r. Then the graph from the first the graph is distance from surface of Earth. You have to calculate these negative values, and there's a just relationship. Inside is not, we're not sure inside, so we present by dotted lines, and again that's a curve which varies, just inverse curve, 1 upon r curves. But you can see as the distance is increasing, gravitational potential becomes less and less, negative means it is increasing. So that's the case, and we define gravitational potential always work done per unit mass. It's SI unit joule per kg, and then its formula is phi is equal to minus gm upon r, and potential g m phi, or potential is formula is minus gm upon r.